This videotape will demonstrate how to cut ACME threads on the lathe. The ACME thread is generally larger and coarser than the V thread. It has a flat crest and root and an included angle of 29 degrees. This design gives the ACME thread a heavier cross-section than the 60-degree V thread, so it is better suited to constant use. A familiar application of this thread system is the lead screw of the lathe. After viewing this videotape, you should be able to write down the safety precautions to be observed in the machine shop and in machining ACME threads on the lathe, write down the procedures for grinding and setting up a tool bit for cutting ACME threads, and write down the steps in machining external and internal ACME threads on the lathe. When working in the machine shop, always wear safety glasses. Remove rings, watches, and other jewelry, and keep sleeves rolled above the elbows. Use a low RPM for machining ACME threads, and keep the tool overhang to a minimum. Check the setup for clearance before using power on the machine. The ACME thread is a helical ridge on a cylinder with an included angle of 29 degrees between the sides of adjacent threads. The crest and root are flat and much wider than those of a V thread. On the lathe, this thread is cut with a single point tool called an ACME threading tool. To grind and set up an ACME threading tool, we will use a high-speed tool bit blank and an ACME tool gauge. The tool gauge is designed with a 29-degree included angle, notches for measuring the tool nose, and a 14.5-degree angle for setting up the tool in the machine. Before grinding the tool, determine the desired thread size. For this demonstration, we will machine a 1 1/4 5 ACME 2G thread. This is a general purpose thread whose specifications can be found in the machinery's handbook. This is a correctly ground ACME threading tool with a 29-degree included angle and the tool nose ground to the correct width for 5 threads per inch. To grind this tool, begin by grinding a 14.5-degree angle, or 1/2 the included angle on the leading edge. Since we are cutting right-hand threads, the feed is from the tailstock to headstock. So the leading edge is on the headstock side of the tool. Grind the relief at the same time. This angle is the total of the helix angle plus 3 to 6 degrees of side relief. So the relief angle should be 6 to 9 degrees. Now grind the trailing edge at 14.5 degrees with 3 to 6 degrees of side relief. This edge of the tool does not require relief for the helix angle, since the helix angle is away from the tool. Check the 29-degree included angle with the ACME tool gauge. To grind the tool nose, hold the tool against the grinding wheel, with the ends square with respect to the length, and grind the nose, allowing 3 to 6 degrees of end relief at the same time. Using the notch on the tool gauge marked 5, denoting 5 threads per inch, check the width of the nose. This tool requires 0-degree back rake, so if it is to be held at a 14.5-degree angle, grind 14.5 degrees of back rake into the tool. If it is to be held in a straight tool holder, such as the quick change tool holder, no back rake is ground. To set up the external threading operation, place a piece of stock in the chuck, leaving enough extended to accommodate the thread plus a tool runout. In this demonstration, we will cut an ACME thread 1 1/2 inches long, adding 1 lead of the thread, or about 1/4 inch for runout. Face and center drill the end of the work. Place a live center in the tailstock spindle and position it in the center hole. A center will support the work and prevent chatter when taking a heavy cut. Turn the diameter of the workpiece to the major diameter of the ACME thread, which is 1.250 to 1.240. Tolerances for the major diameter of the ACME thread may be found in the machinery's handbook. After the major diameter has been turned, place the ACME tool bit in the tool holder. Swivel the compound 14.5 degrees to the right of center, which is 1/2 the 29-degree included angle. Align the tool square to the axis of the work with the ACME tool gauge. The tool is fed into the work at a 14.5-degree angle with the compound, thus forming the backside of the ACME thread as the tool removes material with the leading edge and end of the cutting tool. When the tool is aligned, use the leading edge to chamfer the end of the workpiece to aid in starting the thread. Then move over 1 1/2 inches and undercut a recess for tool runout. This recess must be cut to the minor diameter of the ACME thread, which may be found in the machinery's handbook. In this case, the minor diameter will be 1.030 to 0.998 inches. When the undercut is completed, you are ready to start cutting the ACME thread. Set the quick change gearbox to 5 threads per inch. Reduce the spindle speed to a very low RPM, not more than 1/4 the normal cutting speed. With the backlash removed from the compound, set the dial to 0. Using the carriage and crossfeed, bring the tool in to touch the end of the work. Set the crossfeed dial to 0. Move the tool bit off the end of the workpiece and feed the compound dial in approximately 10 thousandths. Engage the half nut on a numbered line, as we are cutting odd numbered threads, and take a pass on the workpiece. Disengage the half nut when the tool reaches the recess. Back the crossfeed out. Return the tool past the end of the work and return the crossfeed dial to 0. This is the reference point for cutting the thread. Stop the machine and check the work to make sure you are cutting 5 threads per inch. This can be done by using a scale, measuring 1 inch, and counting the threads. Or you can measure the pitch of the thread, which is 200 thousandths. If the number of threads per inch is correct, lubricate the work and continue taking 3 to 5 thousandths cuts to machine the ACME thread to a rough size. A general rule of feeding in on the compound would be not to feed in more than a depth equal to the depth of the thread. Basic thread depth is half of the pitch. For a number 5 thread, the pitch is 200 thousandths, so the depth would be 100 thousandths. When you have fed in approximately 90 thousandths on the compound, start to measure the threads. A quick method of measuring an ACME thread is to fit it to the mating part. A more accurate way is the one-wire method. Wire size can be determined by taking the constant 0.4872 times the pitch, in this case 200 thousandths. Using this formula, we come up with a wire diameter of 0.09744. Lay the wire onto the thread. It should be protruding slightly above the top of the thread. Use a micrometer to measure over the wire and determine how many thousandths remain to be machined. In using the one-wire method for measuring an ACME thread, the reading over the wire should be that of the major diameter of the thread when it is to size. In this case, the reading is over the major diameter. So, feed in an amount sufficient to cut the thread to the specified depth. A more accurate method of measuring ACME threads is the 3-wire method. The size for these wires can be calculated from formulas in the machinery's handbook. The 3-wire method would normally be used only when a very precision thread is required. After machining the ACME thread, recheck it for size with the 1-wire method. If the reading equals the major diameter, the operation is complete. Now we will cut an internal ACME thread using the external thread just machined as the mating part. Place the work in the chuck. Face and center drill. Then drill and bore the work to the minor diameter. The minor diameter for a 1 1/4 5 ACME 2G general purpose thread is a minimum of 1.050 inches and a maximum of 1.060 inches. So we will bore the hole to a diameter within this tolerance. When the hole has been bored to size, remove the boring tool from the boring bar and replace it with a tool that has been ground for a number 5 ACME thread. Swivel the compound to 14 1/2 degrees. Using the ACME tool gauge, align the tool in the boring bar holder. Use the tool edge to chamfer the edge of the internal diameter. This chamfer aids in starting the thread. Set the spindle RPM to a low RPM and the quick change gearbox to 5 threads per inch. Remove the backlash from the compound and set the dial to 0. With the carriage and cross feed, touch the tool to the inner diameter of the work. 0 the cross feed dial. Move to the end of the work. Feed the compound in 10 thousandths and take a pass on the thread, engaging the half nut on a numbered line. Remove the tool, using the cross feed to back it out from the thread and the carriage to bring it out of the hole. Using a scale, check the number of threads per inch. Lubricate the thread and continue taking 3 to 5 thousandths cuts until you have fed out approximately 90 thousandths on the compound. Clean the chips from the hole with a brush. Then use the mating part to check the thread. If it does not fit, remove more material, stopping occasionally to check the internal thread for size with the external mating part. When the external thread screws into the hole with minimum force, the internal ACME thread is completed. Reverse the part in the chuck and face the opposite end. Now the workpiece is complete. To review this videotape, you should be able to list the safety procedures for cutting ACME threads on the lathe, describe grinding and setup procedures for an ACME threading tool, and list the steps in machining external and internal ACME threads on the lathe. The ACME thread is a strong, durable system that is widely used for transmitting motion. Cutting ACME threads on the lathe is an essential skill for the machinist.